Okay, let's look at question 15 of part 2. Now, this is a system of equations question, so I'm just going to do this one question in this video and show you two different ways of doing it. I was actually able to help my niece solve one of these questions. She goes to school in Kentucky and had a similar question. So, solving a system of equations means we need to find a coordinate pair. All right, we need an x and we need a y. So we need an x and a y. So we need to know what each of those are. But the problem is both of these equations have an x and a y in them, which means we can't solve them. So what we're going to do is we're going to rewrite one of these in terms of x. That means we're going to get x on one side by itself. Once we do that, whatever x equals, we can substitute into the second equation. Let me show you what I mean by that. So if I simply subtract y from both sides, I will have x equals 7 minus y. Now that I know what x is, I can take this value for x and I can put it in here where x is. So now my new second equation is going to be 2 times 7 minus y equals negative 1. Okay? Well, what you should know, actually, let me scratch that off. Try again. So, 2 times 7 minus y, and then we still have the minus y equals negative 1. There we go. That's better. So, what we notice now is I don't have any x's. And because I don't have any x's and only y's, I can combine them and I can solve this thing. First, I need to do distributive property. Okay, so hopefully you haven't forgotten the distributive property. So 14 minus, so 2 times 7 and 2 times y, so 2y. And now we're still going to have minus y, and it's still going to equal negative 1. All right, well, now what you can do is you can simplify, combine these y's together, and I have 14 minus 3y equals negative 1. All right, now I'm trying to get y by itself. So if I subtract 14 on both sides, I'm going to run into negative 3y equals negative 15. Now I'm going to stop there. I'm not going to do the whole thing, but just give you a hint. If you divide by negative 3 on both sides, you can figure out what y is, and that will go here. Right? Now, once you know what y is, whatever you get for y, all you have to do is take it and substitute it back into this equation, and then you can solve and figure out what x is. Okay? So that would be a kind of the substitution method of solving a system of equations. Now, there is another system called elimination, and I actually didn't teach this in class, but I want to show you now just in case you find that helpful. So if I line up these equations kind of like this, my goal is to see if there's a way that I can eliminate one of the variables. If I eliminate one of the variables, then I can just solve for the variable that's left. So I noticed that this is 2x, and it would be very easy for me to turn this into a 2x by multiplying it by 2. So if I simply take this whole equation and multiply everything by 2, well, what would that be? Well, it would be 2x is 2x, right? 2 times y would be 2y, and 2 times 7 would be 14. Okay? So now I have 2x plus 2y equals 14. And I'm going to treat this whole thing kind of like a subtraction problem. Well, 2x minus 2x is 0, so that's beautiful, right? Well, you've just now eliminated this variable, hence the name elimination. 2y minus negative y, remember, subtracting a negative is like addition, so that would be 3y. And then 14 minus a negative 1, once again subtracting negatives like adding, so 15. And now we have the situation where all I have to do is divide by 3 on both sides to figure out what y is. And then once again, when I know what y is, I would do the same thing as before and substitute and then solve to figure out what x is. So hopefully this is helpful with systems of equations.